All right, so before we start into this video for today, we are going to define something real quick, and that is conjugation. Okay. Conjugation happens when the pi orbitals, remember how earlier I talked about we had these p orbitals? And when we put them together, it kind of like this, we got like a pi bond. Yeah. Now, when we add another one, we get something called a pi system. And conjugation is when we have a pi system, and they're all in the same plane with one another, and they are overlapped. Life is good. The pi system is working. They're all in this plane. Okay, this green plane here, and they're all overlapped. All right. If one of our p orbitals in our pi system were to rotate like this, that pi system is broken. It's no longer a system. This isn't a pi bond. It doesn't work anymore. We don't have conjugation. Conjugation is when we have this pi system. All right, they're all in the same green plane. They're kind of overlapped, so they kind of create these like pi bonds. Not exactly full on overlapping pi bonds, but you get the point. And this stabilizes a molecule, makes it nice and stable. And with that, it's time to get into biphenyls. All right, so biphenyls is when we have two of these phenyl groups, or what are they called? Cyclohexane 6-carbon rings, kind of attached to each other. So hopefully I can just can see it from here. They're attached. All right, by this bond here, two phenols. On their sides, I put some substituents. In this case, both white and green are going to be hydrogens. For now, at least. For now. And something cool about this biphenyl is that it can rotate. It can rotate about this bond here in the center. Rotate. They are rotating. And when it does that, it gets different conformations, rotations, conformations. All right. So basically, the worst conformation ever with the highest energy for this dude is when you've got them like this. They are flat. They are like this. Hydrogens are connected. They are like in front of each other. Look at that. This is absolutely horrible, disastrous, the worst thing that could ever happen. Why? Well, it's because they have those flagpole interactions we were talking about earlier that happened in the book conformation. Okay, also known as the hydrogens are encroaching up on each other's space. They're kind of like this, like getting all up in each other's faces. Grrr. Okay, so they're getting up in each other's faces. It is annoying. It causes strain. It's not fun. Steric clashes, strain, flagpole interactions between these two. That's why you don't want it to be like this. Okay, well, why don't we solve our problem and just, bam, move it so that one of them is flat and the other one is 90 degrees to it. See it like this a bit better. You might be able to see that is kind of 90 degrees. 90 degrees. Hopefully you see it. It's 90 degrees. Yeah, well that's okay, but oh man, it's really not the best because guess what? There's no conjugation. One of the pi bonds that were all like really nicely aligned, kind of like let me get some of these. Like this dude and remember how the pi bonds are all really well aligned? 1, 2, The third one, they were all aligned like this, and they had conjugation happening between them. Oh, these stuff are pi bonds. Let's pretend they're pi bonds. Yeah, well, one of them just went like that. You make it 90, okay? Good, bam, 90 degrees. So this 90-degree conformation here, pi bonds became like this, and we broke the system, the pi system. We broke it. What do we do? Well, we just rotated the molecule again, so that it is between 0 and 90, because if 0 and 90 are the worst things that can ever happen, then let's just go right in the middle. And we get this very favorable 45 degrees. Hey, our hydrogens right here are not overlapping, so there's no steric clashes, there's no fractal interactions. And guess what? There's some conjugations because our pi system, we fixed it. It's like this now. There is conjugation between them. It's not like this where it's broken, it's fixed. Like this. Life is good. The pi system is back up and running, and we have stabilization from conjugation. Oh, and the hydrogens are also pretty stable. All right. So now what happens if we replace these hydrogens with some bigger molecules? Well, let's go ahead and take a look. Let's replace this one right here. Let me get another color. I think this one's nice. This one's pretty big. Yeah, I'm gonna play a big one. Got a big one right here, okay? So what happens is that there's gonna be some pressure between this hydrogen and this big one. And you know what? Let's go ahead and make this even bigger. Add in like a bunch of stuff, you know, like just a lot of stuff in there. There we go. Got this super big molecule attached here. Super big molecule, hydrogen. All right, actually, let me hold it like this, might be easier. Super big molecule, hydrogen. And what happens is that we end up creating some pressure there, right? Because this molecule here, it's huge. It's starting to go into this hydrogen space. So what happens is, to kind of avoid that, the ring starts to flip a bit closer to 90. Starts to not flip, rotate. There's a lot of repulsion between this big guy and this hydrogen, right? It's getting all up in its space, bam, bam. So the ring's like, okay, well, I want to move away from you. It's like, I want to move away from you, ew. Just rotates a bit more. And now you can see that the ring went from this really great 45 angle to something a bit closer to 90, like an 80-degree angle, right? And it creates a bit more of a twist. And unfortunately, what happens is that sometimes these molecules get so big that you can't rotate back. You can't, because this dude is blocking it. Like, it's literally like blocking. You can't rotate anymore. You can't go back to the way things were. You can't, because this dude right here, it's so big. There's so much repulsion. This guy doesn't even want to near him. The only choice you have is to go forward and closer to 90. So again, can't go this way because this dude is huge and he's blocking you. So it's like, I can't go that way. This dude right here blocking you. This guy can't go. So you gotta go closer to 90. And because that lock in place happens, you end up having chirality, right? You get this conformational chirality. Okay. All right. So I'm not too sure how to draw this, but I'm going to try and show it with like a Newman projection. So let me just move my hair a bit. All right. Newman projection. So we've got our circle here. We've got our front carbon ring, Okay, so we're looking kind of towards it. Got our two substituents on the side. Call this a hydrogen, big fat dude. And then we've got another hydrogen here. So guess what? I mean, as you rotate this right here, it's not going to want to stay close to that guy, right? So this 45-degree angle right here, this hydrogen is just way too close to this fat guy. It's gonna have a lot of repulsion between them, like they're getting up in each other's face. And it can't keep going either because there's way too much repulsion. So instead, it's going to be pushed back towards having this 90-degree, and it's going to be stuck there. It's going to be stuck between 90 and 45, I guess. I want to say 45. It's going to be stuck there in some place, somewhere, depending on the size of one of the substituents. And what does this end up resulting in? Well, chirality. You can't rotate fully or freely, so you're obviously going to have some differences going on right there, right? So like demonstrate that a bit better. Go ahead and make this dude a bit smaller. Copy, paste. Well, we've got some symmetry going on, right? And let's just number these randomly. I know it's not CIP rules. Let's go 1, 2, 3, 4. 1, 2, 3, 4. Sweat. Rotating to the left. This one's up being an S. Rotating to the right. Chiral molecules, enantiomers. You got them. All right. That's it for this one. Pretty short video. As always, if you have any questions, feel free to check the website and ask in the Google form that is posted. Link to the website in the About section of the YouTube channel. Feel free to go ahead and subscribe and turn on some notifications if you found this helpful. If not, then just ignore it. And yeah, all right. Awkward goodbyes. Stop recording.